Hello everyone, good morning. So let's wait for 5 more minutes, okay? Then we'll start. I'm audible, right? Please confirm.
Yes, sir.
Yes, sir.
Yes, sir.
Chiku.
Yeah, okay, so I think we can start. So hello everyone, good morning once again. So there are a few updates. We have released the SQL practice question. Okay, you can check the PostgreSQL resources folder. Inside that we have uploaded the 30 questions for SQL practice based on SQL query. Okay, so please practice that, and we'll release the solution of those questions on 18th of February. Okay, so if you have any doubt regarding any question, or if you want to discuss the solution or code, you can post it on the discourse. Okay. And the second update is okay. So we have released the mock test for quiz one. Okay, so please attempt that mock test. Okay, and we'll discuss that mock test on Saturday session. Okay, and yeah, so we'll start with the week 5 now today. So how many of you have watched the week 5 content videos? At least first 3 lecture. Okay, Class, Bhavya, Viraj. Okay, great. Yeah. So first we'll be starting with the few questions. Like we'll take few questions on PIDEC platform. Then we'll take your doubt. Okay. Okay. So let me share my screen. Mhm. Okay. So it's visible, right?
Yes, sir.
Yeah. Okay. Just go to joinpd.com and enter this code. I will also share the link in the chat box. SQL practice questions are inside the PostgreSQL resources folder. Okay, so if you go to portal, you can see on the left hand side at the bottom there is Postgres SQL resources folder, right? So just go to that folder. You will get a like a Google Drive link. So in that we have uploaded that file. Okay, that PDF file. We have online proctored exam in this term. So please practice those questions. Okay. 14 students connected.
Sir, I had a doubt regarding the programming exam.
Mhm.
So on the course page, it says that there is a Viva or a programming exam.
Viva,
Do
yeah.
we have to choose, or will the choice be made for us and then we have to select the slot?
No, no. We'll decide like for online proctored exam, but there will be it will conducted from home, home only, right?
So there will be a programming exam and not a Viva, right?
Yeah. So this time probably we'll have online proctored exam.
Okay,
So the
sir.
pattern of the exam will be sharing with you soon. Okay. This time no Viva. Yeah.
Okay, sir. Got it. Thank you. Thank you.
Excuse me.
Hmm.
Yeah, there are 30 questions you have said. I mean, where it is?
Asim, can you please speak louder?
Yeah. I mean, there are 30 practice questions.
Yes.
In which group? SQL query practice.
Inside the PostgreSQL resources folder, you can see SQL practice questions PDF, right?
Yeah. SQL practice questions.
There are
But
30 questions. Yeah.
only the practice questions, or
No, it is for practice only. So you can try out the SQL query for that. Okay. Same question, like same difficulty level question, can be asked in online proctored exam.
Okay, from this practice questions, right?
No, not from this 30 question. Questions will be different, but difficulty level will be same. Yeah.
No. I'm asking the SQL query practice assignment, right? From there, right?
SQL query practice assignment.
No, I mean, where the 30 questions is. That's
So that is only for your practice.
yeah,
It
but
is
I'm
not
not.
graded. Yeah.
Yeah, I got it, but that's unclear. But how can I get that question? That's I
It is
mean,
there on the portal. Right.
where is the leak?
Wait, I will show you one minute. Yeah. Yeah, SQL practice question inside the Google Drive. Yeah.
Okay.
Yeah, you can see the course page, right? Here you can see PostgreSQL resources unit. Then you can see resources from instructor. And here is the link for that. Okay. Here you can see SQL practice questions. Yeah.
Okay. Thank you.
Yeah. Okay, so let's start the session. Okay, start class. My screen is visible, right? Week 5 live session.
Yes, sir, it's visible.
Okay. Yeah, so here is the first question. This question is based on simple functional dependency concept. Okay. Okay, only 9 responses as of now. Okay. Okay, we'll wait for 1 minute, then we'll discuss only 13 response. Okay.
Sir, we have to write A, B, C, D or that whole statement.
No, ABCD only.
Okay, thank you.
Okay, I think we can discuss it now. Show the response. What happened? Yeah. Okay. B, C, A and B, option A and B. 1, 2, 3. Okay. A, B, B,
Okay, so hello, good morning, everyone. So the ones who have given C or the third option as their answer, can you please unmute yourself and tell why? Why hostel ID determines room ID?
Because there is total dependency between hostel ID and room ID. Every room belongs to a certain hostel.
You have to, like, have you gone through the table? Like, can you see the table and then tell why hostel ID determines room ID?
So basic definition of functional dependency is that, see here in the case of hostel ID, determine room ID, right? So for every hostel ID, there must be unique room ID, right? So hostel ID uniquely determines room ID, then we can say that this functional dependency hold true. Now, can you please explain here? Yes, any one of you, yeah. Okay, those who answer option A, B.
Yeah, can you explain why A and B are the answers? Anyone?
Yeah, actually, here it is saying that choose all functional dependency. So if I look into the fields,
Yes.
we can see that sometimes, I mean, all functional dependency means all case should be considered, right? So I answered B because SID and sometimes the department ID and hostel room ID maybe.
B
Depends upon
con-
it depends upon the what kind of query I'm going to place it.
okay, so you have answered B, right?
No, B.
Yeah, B, right? SID determines S joining date.
Yes. So immediate is exactly not declared over here, but this is the most suitable case.
Okay, yeah, that is what I'm asking. That you have answered B, right?
Yeah, yeah.
Yeah, okay. So can you tell why B?
Yeah, I mean, here it is saying that choose all functional dependency applicable to the given table, right?
Yes.
So functional dependency will be required for the different cases. It's not the
Yes.
single one, right?
Yes. So
That's why.
can you tell me the like rule for the same tuples? If there are same tuples in the determinant side, then which rule we have to follow?
Ma'am, for same S names, we don't have different SIDs. Then we say SID determines S name.
For same S name,
Yeah, ma'am.
yeah, you have same SID, right?
Yes, ma'am.
Yeah, so we can say this that SID determines S name.
S name.
I think option 3 is wrong, ma'am, because S3 has two different room IDs. And
Yes,
it's
exactly. That is, yeah, that's correct. As you can see, H3, there are two same tuples, right, in the hostel ID. But as we can see that the corresponding like values in the room ID are not the same. So hostel ID does not determine room ID, right?
yes, ma'am.
Okay. So any doubt in this question, anyone?
Yes, ma'am.
Ma'am, doubt about option 1.
Okay.
Yes, S004 also named Rishabh and S02 also named Rishabh.
Yeah. Okay. So what we have to consider as at first is that you know that the left hand side one is known as determinant and the right hand side one is known as dependent, right? You are aware of it, right?
Yes.
Okay. So the first thing that we need to consider is that if whether there are any similar tuples in the determinant side. So as you can see in the table, we have S001 as and again in the fourth row S001 is repeating, right? So what now? So now we have similar tuples, right? So what we have to look for is that the corresponding value in the S name is same or not. So as we can see that S001, the name is Monty, and again in the fourth tuple, again S001, the name is Monty. So so this is determined, right? But if, say for example, the determinant has different values, so we won't be going further for checking the corresponding dependent values. Like the what I want to say is that the value of determinant is unique, right? So it does not really matter whether the value of dependent is same or not. Is it clear? Am I clear? If I'm not clear, please let me know.
Ma'am,
Okay.
in case of total dependency, there is functional dependency.
Yeah, hello? Yes, Prashant, please go ahead.
Is in the case of total dependency, there is also functional dependency.
Total dependency means?
If any attribute is total dependent on other, then that will also form a functional dependency between them.
But for the first is just see S002 Rishabh and S004 is Rishabh, S002 Rishabh. So it doesn't make sense, right?
Okay, let me explain it. Suppose this is the first SID is the alpha and second is the betas, right?
S name.
Okay, yeah, S name is the beta. We have to check only the alpha part. If there is the unique, all value is the unique. Yeah. Hello.
Yes.
Yes, you are.
Are you able to follow me? If there, you have to check the S1 first. In the S1, what is the corresponding S name is the Monty.
Monty,
yeah.
Yes.
And second S name is similar. The same is the Monty. Is it okay? So what is the definition of that? If there is a pair of two tuples T1 and the T2, then the Y value should be same. And here you can see the first Y value are the same. S is T1 X is same, T1 SID and the T2 SID. These two means this row 1 and what row 4 is the same, and the second value is the S name is also same. Similar way you can check the S002 and the S002 in the this sixth column and the second column. You can see the same name is the Rishabh. So
Yes,
it satisfies the functional dependency.
No,
Yeah.
but is S004 is Rishabh also, same name.
Yeah, it may be possible. But you have to check if another S004 is there. Suppose there is a 7 column is there. S004 is there and something like that. There is something suppose there is a name is the Kumar. Then it violates the functional dependency condition.
One second,
right?
you talk. No, you unmute.
Madhav, can you mute yourself?
Yeah.
Sorry. Yeah.
Am I clear?
Yeah.
If another instance is there for the S004 and S name is the suppose Kumar, then you can see it violates the this functional dependency condition. But it may be possible so the SID same student name here may be possible in a class.
Yeah, that is possible because Rishabh is the first name, so maybe surname will be different.
Yeah. Yeah, we only have to check this SID part. Yeah. If there is the same duplicate value is there, means here you can see the S002 and this second row and the sixth row S002 and the corresponding name is the Rishabh is there. So it is similar, right? It satisfies the functional dependency.
S name can be duplicated.
Yeah. And the second condition, you can also check the SID is determines the
as joining date.
as joining date. Here can you see the all the are the same value, same value. So whatever is the value on the left hand side means the alpha value.
Yeah.
So
Alpha value is same. Yeah.
yeah.
No, alpha value is
No,
different.
alpha value, yeah, different. So
Alpha
we
value different, but Y value.
yeah, a similar way you can check it.
Yeah, joining date can be same. That's not
Yeah.
the problem. Yes. Many students can be joining similar.
Yeah. So no need to confuse about that. So the beta side is there is the reserve is you have to check to the alpha side means left hand side. Yeah. Am I clear?
Yeah.
Okay, so also for the third option, as you can see that there are all the other values are unique. Just the first two rows, as you can see, are H3 and H3, right? So we have the same value for the determinant, right? So what we have to look for is that the corresponding values of the dependent are same or not. So as you can see that the first row, H3, has the corresponding room ID as R2 and the second H3 has the corresponding room ID as R4, right? So what that means is that hostel ID does not functionally determine room ID because the values are not same, right? Because it does not follow the rule, right? So Prashant, am I clear?
Yes, ma'am, I understand that, but I was asking something different. Means not in this table. Like there must be some some room common in both hostels.
Yeah.
Which is not in table. If that is case, then
yeah, there may be n possibles, but you have to look at this point and whatever's the instance available to you. Yeah.
Right now you have to follow that the table that we are showing, right?
Yeah, in this data that is not.
Yes, correct. The hostel ID does not really determine room ID. So Prashant, are we clear?
Okay, ma'am.
Yeah.
Thank you.
Okay. So anybody have any doubt in this particular question? Okay, so I think we can move ahead, sir, to the next question.
Okay.
Okay, so here, if the question says that if the hostel ID determines S department is a valid functional dependency, then what will be the possible values of S department at positions indicated by A, B, C? As you can see in the table, there are like in the second row, in the fifth row, and in the sixth row, the values are not given. So what you have to figure out is that what will be the like a value in that particular positions. If hostel ID, if given the condition that hostel ID determines as department. So I hope the question is clear. If anybody have any doubt, you can please ask. Or else you can answer.
It can be CSC.
You can write it down, right, on the text.
Yeah.
You can
that would be
A
better.
equals to this, B equals to this.
Yeah, that's correct. Yes.
Okay, I think we can discuss it now. Yeah. Okay. Mhm. What happened? A equal to CAC, B equal to CAC, EC, ME. Can take any S department. Okay.
Yeah, so the
Why
answer is
or okay, we'll see. Yeah. I think no one has given the correct answer. I think A, C, C, B, E, E, C, I, T. Let's see.
Given the CSC, BME, and EC. C.
Oh, sorry, next question. Right? Yeah, so this is the functional dependency, right? Hostel ID determine S department. Yes, anyone can unmute yourself. Yeah. Can you tell me your approach?
I think A should be same as previous CSC, and B and C are different from all the three. CSC, ME, EC, B or C can't be any of these.
okay. One thing, can H6 or H4 be CSE?
Yeah, it can take the value CSC.
Yeah, H4 can be EC.
Yes.
Yeah. See, here H3 is determining S department, that is CSE. And here also, so that this condition should be valid, this functional definition should be valid, this H3 must determine the same department, right? So A equals to CSE. Now let us check for this condition, B part. Okay. Now, do you have any tuple having hostel ID S6? No, right? So it can take any department, right?
Yes,
Same
sir.
for H4 also. It can take CSE also, ME also, ECE also, right?
But for H3, it can also take any other, right?
For H3.
Uh-huh.
No, we
If
cannot, right?
yeah.
As the condition is given, right? That hostel ID functionally determines S department. So if we take something else like a ME or EC, then that condition won't follow, right? Then that condition won't hold, right? Because H3 must the corresponding value of H3 must be same, right? That is how it will be functionally dependent on S department.
Okay, clear. Yeah.
Okay. Yes, sir. Sir, you can continue.
Yes. Any doubt? Anyone?
Sir, so when we are doing this kind of questions, then we have to basically look at the dependency first, right?
Yeah, first dependency. What are the dependencies mentioned in the question? Yeah, this thing.
And then we refer to the relation and check the dependencies in the relation and where do they stack up.
Yeah,
Okay.
because yeah, here we have mentioned is a valid functional dependency. To hold this condition, we have to find out the ABC, right?
Yes, sir.
Yeah.
Ma'am, H6 can be CSC.
Sorry,
H6
H6 can be, yeah, it can be CSE as well.
Ma'am, if then that's the case, then H3 has also CSC and H6 also
Yeah.
belongs to CSC department. Then
Yeah,
two.
yeah. Please go ahead. Sorry. Hello.
Yes, ma'am. Yes, ma'am. Wait a minute.
If you see the definition of functional dependency, say alpha determine beta, alpha 1 is determining beta 1, then alpha 1 cannot determine any other part left for beta, right? It should determine beta 1 only. So that this alpha determine beta functional dependency holds true, okay, for that condition. So if you see, we'll not check for the beta part, okay? Beta part can be same here, like in this case, so this is alpha H3. This one is beta CSC, right? So this alpha beta to hold to this function dependency holds true, alpha determine beta, H3 must determine the CSE department. Okay. So it's okay that S6 also determines CSE department, that is fine. But for each record for this hostel ID, there must be a unique record in the S department, right? So H3 is determining CSE only. S6 can also determine CSE. But if we add one more record S6, then that it should also determine CSE if we consider the value of B. Okay.
Prashant, that is clear, right?
Yes, ma'am. Yes, ma'am. I just little bit.
Okay. Anybody have any doubt in this question? Okay, so sir, we can move ahead, I think.
Correct options. Okay.
Yeah, so in this question, we have set of attributes, not just a single attribute. So you'll have to identify in that manner. So please give your answers. We'll wait for some time.
Hello.
Yes, yes, Sachin.
Yes.
Oh, sorry, Vignesh. Yes.
Yeah. So for the previous question, right? Both H4 and H6 can take any one of the three variables, CSE, ME, or ECE.
Yeah.
Okay. Okay.
Yeah, it can be any of it. Like it can be EC, or both of them can be CSE, both of them can be ME, both of them can be EC, or they can have a very, it can vary as well. Right?
Oh, okay. 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 Thank you.
Okay, there are 12 responses. I think we can discuss it. Okay. Whatever. Yeah. Yeah. Okay. B, 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 D, none of the above. Option B, option B, option C. Okay. Yeah. Okay. So anyone can explain this question? Yeah. Which is the correct option and why?
Yes, ID can determine joining that. Then any superset of it can also determine the joining date. So option B is right.
Superset means?
Superset means bigger set
No.
that yes.
Okay. What you said? Can you please repeat? Superset of SID.
Yeah. That yes ID and yes name definitely determine joining date, because yes ID when yes ID alone can determine yes joining date, then yes ID and yes name definitely determines the joining date.
No. That is not the case. See, here you have to take the combination of both the attribute, okay, sname and SID. So sname and SID. So S001 Monty is determining joining date, okay. So Joining date is same. Okay. So this functional dependency holds true. Now, if we consider, we have to consider the combination of this attribute H02 and Rishabh, H03 and Neha. Okay. In this case, all right hand side is same. So this functional dependency will hold true.
If we remove S name, then also SID can determine S joining date. Then S name is only for the sake of option. It doesn't matter. Then it definitely determines joining date.
No, not like that. See here, you have to take the combination of an attribute. Okay. Say, okay, so in this case, okay, you know that both alone can determine joining date. Let us take example. Instead of SID, I will take hostel ID. Okay, so S name, hostel ID determine joining date. Now, in this case, can hostel ID alone determine joining date?
No.
Yes, we can determine, right?
Yes.
Yeah, the values are same.
Yeah, joining date can be determined from the particular two cases.
Okay, just 1 minute. I think
many students got confused about that's the future case. Don't confuse about that. Whatever you have tables given, and based upon that you have to give answer.
Yes.
Just 1 minute. Yeah, it's visible, right?
Yes, sir.
Yeah, say what is the basic definition of functional dependency is if alpha determine beta, means alpha should uniquely determine a beta here. Okay, so our first functional dependency was SID determine S name, right? In the first question.
Yes,
so here alpha is S001 determining the name on T. Then let us check for same SID, yes, 001 is also determining the on T. Then 002 Rishabh, 02 Rishabh, 03 Neha, and 004 Rishabh. So this functional dependency holds true here. Okay, SID determine S name. Means there must be a unique record. It should uniquely identify the beta. Say that is alpha 1 determine beta 1. Then alpha 1 should determine beta 1 only. Okay, it cannot determine beta 2. Okay. This condition should this alpha should uniquely identify the beta. Okay. Now, now what was the question? The combine, right? So what Prajwalit, right?
Yes.
Yeah. What Prajwalit is saying, if SID is determining S name, so if we take the combination of SID with any other attribute, that will determine S name, right? So that was your conclusion, right, Prajwalit? No, that is not the case here. You have to take the tuple, means you have to take the combination of both the attribute. Okay.
Okay.
See here, if it is alpha, not let us take A, B, C, A1, A2, A3, A4, and say this is B1, B1, B2, B3, C1, C2. Okay, yeah. Now tell me, A determine B hold true or not for this case?
What's true? What's true?
A1 determine beta 1, A2 determine beta 1, so it determine beta. Okay, so this will hold, right?
Yes.
Now let us discuss A. Okay, now A determines C or not? Let us check. Alpha 1 C1, A2 C2, A3 C3,
Not.
and A1 C3. That it is not determining, right? So this condition does not satisfy. Alpha determines C is not hold true here because this tuple is A1 is determining C1 also and A1 is determining C3 also. So this condition violates here, right? So this is not true. Now check for A, B determines C. Now in this case, you have to check the combination of an attribute. Say A1, B1 is determining C1 also, and here A1, B1 is determining C3 also. So this functional dependency will not hold true here. You have to check the, you have to take the combination of an attribute. Okay, it is not like that A1 is sorry, it is not. Sorry, it is not like that A is determining beta. Then if you take sorry.
Sir, may I? Yeah.
Yes,
Yeah. Here you can see the in the A determines the C. Here is the all the attributes. If all the attributes are the distinct A1, A2, A3, and the A4, then it always determines the alpha to beta because it is always satisfy the T1. There is no pair of the tuples T1 and the T1 means the suppose it takes the first two tuples T1 row 1 and the row 2. Is it okay? Are you able to follow me?
Yes.
Yeah. So if alpha determines C, if first we have to check if all the attributes are distinct or not. If there is the distinct, then it always satisfies the alpha determines C, because there is no case arise where two tuples T1A equal to T2A. So the problem arises only when there is the another tuples means row 1 and the row 4. Here you can see the A1 and the row 4, you can see the A1. Then we need to check every time it will determine the same value.
Yes.
Is it clear? Similarly, in the tables, you can see the S1 determines the Monty. So every time the same SID will always determines the Monty. Is it clear?
Yes.
Yeah. So I think in the similar way you can see. And the here one thing you need to notice the S underscore join S joining date. Yeah. Here you can see all the value are duplicate value.
Yes.
So whatever the tuple in the left side means SID is always value the same in the beta side.
Yes.
Is it? I think you.
Yeah. This time, so C should be all same.
Yeah. So suppose if there is the one case is there, alpha 2 determines the beta. To solve this kind of answer, you can see the here S joining date. If here the checks the beta side, if all the value are the duplicate value, means same value. So it is always holds the functional dependency. Am I clear? In the second option you can see S joining date is the always this value or the same value. If same value is there, so no need to check for the left hand side. Are you able to follow me? Yes.
Because it
and
is same date representing different.
Yeah. And if there is the and the previous problem in the second question is there, hostel ID determines the S dot department. Here you can see if all the value are the unique, but here is the one row H3 is two instances there S3. So that's why it H3 always returns a CSC. That's why A equal to CSC is the previous problem. And the BC can whatever's the value of the BC, not depend upon, because H3 instance is not H6 instance is not there. I hope I'm able to clear your doubt.
Yes, sir.
Yes. Any doubt, Rajwali?
No, sir.
Okay. Sorry for that. Okay, we'll move on to next question. Okay. Next question is here. It's visible, right? Here, Dick.
Yes, sir.
Okay.
Yes, sir.
Now here you have to find the closure of AC. Okay. C is a combined attribute, A and C.
So basically, we have to find the closure of SC. You consider a relation R and the given attributes A, B, C, G, H, and given functional dependency A determine H, GC determine B, and CH determine B. So you have to find closure of SC.
So we will wait for 2 or 3 minutes. After that, we will discuss. Is that Anjana? Okay. Over.
Yeah, sure. So I think we can discuss now.
I can see only 10 responses here. Okay, I think we can discuss. AHCB. Okay. ABCH, ABCH. Okay, great. So anyone can tell me what will be the closure of AC? How to find it?
Yeah, anyone can unmute yourself and tell like how you have find out the closure of AC. Anyone?
Yeah, it's for AC we have first dependency from A as H. So we'll add ACH.
Okay, so why we will have AC? Can you tell?
Yeah, because it is trivial.
Yeah, that's correct. Okay.
So we start with
ACH.
AC. Yeah, and from A it is H.
Yes.
So from CH it is B. So
Correct.
ACHB.
Yes, that's correct. Very good. Okay, so if anybody used some different approach, I saw an answer that had G in it. So can anybody unmute and tell why?
Actually, I'm not sure about this.
Sorry.
Because I didn't go through this chapter, so let me go.
Okay, so you are not aware of
No,
like how to figure out the closure, right?
Yes.
Okay. So
I'm sorry.
I'm one doubt.
I'll do
Yeah, Prajwal, please go ahead.
Ma'am, if A determines B, then AC determines BC. Does it imply that A determines BC?
Sorry. If A determines B.
Yes, and AC determines BC. Then can we infer that A determines BC? Are you able to hear me?
Anjana, can you write the functional dependency?
I'm writing this one.
Okay.
What happened? Yes, Prachulit, can you please repeat? Okay.
If A determines B.
Okay. A determines B, okay, then
AC determines BC.
AC determines BC, okay.
So from here can we infer that A determines BC?
A determine
BC. Is it possible?
So is
No,
this
it's
question
not
related to
possible.
the like the question, or are you using some axioms and then trying to?
I am asking for my doubt's sake, not related.
No,
to
it's
this.
not possible. It's not possible.
And because in earlier question also I have implied some this type of my logic, and I say that name ID and name and yes ID determines uniquely yes joining that.
Okay, so is this given function dependency, right? And based on that, you want that whether we can infer this function dependency or not, right?
Yes.
So basically, what you are doing, you are augmenting the C with in the first function dependency.
Yes.
So you are getting AC determine BC, right?
Yes.
But how you can say that A will determine BC?
That's in my doubt. If we can say or not say.
No. You have to check first the possible combination using the Armstrong-Anderson. Did you check that? No, right? So if we argument with AC BC, then we'll get AC determine B, AC determine C. No, it is not possible in this case for given set of functional dependency.
Okay.
Yeah.
I have one doubt. So you told that AC is one trivial, right? How did we arrive at that is a trivial that AC determines B?
No. She said that AC determines AC is a trivial functional dependency. So are you aware of trivial functional dependency? What is trivial functional?
No, sorry, I don't have a.
Okay, so in trivial functional dependency, what happens is that, say for example, sir, can you write it down? Or sir,
Yes.
Say for example, we have A determines B. So according to trivial dependency, B should be a subset of A. Are you getting my point?
Okay.
Say for example, we have AB determines B. So that will be considered as a trivial functional dependency. Why? Because as you can see that B is a subset of the determinant, right? That is clear, right?
Yeah.
Yeah. So in that way, A can determine itself as well. That is also a trivial functional dependency criteria. Obviously, if you think a little bit, like A can determine itself, right? Because the values will obviously be the same.
Yeah.
You're getting my point, right? So that is how she said that AC determines AC. It is because of the trivial functional dependency. Right? Is it clearing the doubt?
But based on the given functional dependency, how are we able to arrive that that it is a trivial? Because we don't have any relation, any functional dependency that tells AC determines A, right?
AC determines C.
Sorry. Yeah, AC determines C.
No, she did not say that AC determines C. She said that AC determines AC. So that is a trivial functional dependency. A particular attribute will always determine itself. How? By using the trivial functional dependency.
Oh, okay. Understood. Okay.
Right.
Thanks.
That's clear, right?
Yeah.
Okay. Anyone else? Any doubt? Or we should move to the next question, I guess. So we can move to the next question. Yeah, so here R is the relational schema and it consists of these attributes A, B, C, G, H, I, and the functional dependency set are given, that is A determines BC, GC determines H, and B determines I. Now we have to, this is a MSQ question, so we have to find out all the correct options according to the given functional dependency set. So yeah, this is, as I mentioned, this is an MSQ, so there can be more than one option, right? That is correct. So you can, give the answers accordingly in the chat box. We'll wait for some time.
Okay, so there are 10 responses. Let's see the response. D, B, C, D, B, C, D. Okay, option B, C, D, D, C, B. Okay, great. Yeah. Okay, so just 1 minute. Okay, now anyone can unmute yourself and tell me how did you approach this question? Is how to approach, like how to find a candidate key or super key? If anyone, those are given the answer. Okay, so if there is consider the relation R, okay, if a relation R is given and you have a set of functional dependency, then how to determine whether which is the candidate key or super key? Okay, so you have to take the closure of an attribute. Say when I say a key means if you take the closure of candidate key or super key, so that closure should determine all the attribute present in the relation R. That should determine the relation R. Okay. So if you take the closure of any key, it should give us the whole attribute present in the relation R. Okay. So yeah, those are your answer, like B, C, and D. Can you please unmute yourself and tell me how did you approach this question? Anyone? Yeah. Okay. First, tell me how to find the candidate key. Okay. Consider this is a question, and tell me how to find the candidate key for relation R.
Sir, for a given, for example, here they have given AGI, and if AGI closure gets all the attributes of relation R, and if there is, if we are not able to reduce the AGI to AG or AI, something like that, then we say it is a candidate key.
Okay, so can you tell me the closure for this?
AGI BC, and
so AGI itself is one AGI, right?
Yeah, we get everything, sir.
Yeah. So then, if you take the closure of AGI from A, we will get BC, right?
BC, yes. Sir.
And from B, we'll get I. So already I is there. And from G and C, we'll get H. So it will determine all the attributes, right? Hello.
Yes, sir. Yes.
Yeah. See AGI. If you take the closure of AGI from A, we will get A, G, I, B, C. Then if you take the closure of this, then we'll get A, G, I,
B, C, H.
C, H. Okay. So from this functional dependency. Now we have to check whether this combination of attribute is minimal or not for candidate key, right?
Yes, sir.
So how to check that?
If
we need to check the subsets of this AGI and check, yeah, uniquely depends all the attributes. So if we take A, so we will get A, B, C, and B will
First,
I.
we're taking the closure of A only, right?
Yeah.
Okay. Tell me.
It will give A, B, C.
Okay, from this we'll get A, B, C. Okay. Then.
And from A, B, C closure, we will get A, B, C, I. From B, we will get.
Yeah, from B determine I, will get A, B, C, I, right?
Yeah.
Right, no? Yeah.
So it is not, this is not covering all the attributes. So we can't take this, and then we can take AG. If we take AG, we will get AGBC from here. And
ABC, we will determine ABC then.
And then from GC we will get H.
GC, okay, from GC we will get H.
And from B we will get I.
Okay. So AG is the minimal of this, right? From this attribute set.
Yeah.
Do we need to check the combination of AI and GI also?
A and J.
It's not possible, right?
Yeah.
We need to check the combination of AI also.
No, I don't. AI. Okay, so from A we will get BC.
You will not get all the attribute here, right? AI. From A we will get BC, and from B determine I. It is I only, right here. Yeah, so it's not determining all the attributes. So this is not valid here. Same for GI also, right? GI. Okay, we will not get anything. Okay, GI trivially. Okay, so this is for only first option, right?
Sir,
Any question? Yes.
sir, hello, sir.
Yes.
We can directly from AGI, we can directly omit I because we can see that A is determining I by transitivity. So we can directly omit I, no?
Yeah, we can do that, but we can follow this procedure also.
Okay.
Yeah. Okay, but my question is, but my question is, just consider this part, okay? Don't consider the option, just this one, and tell me how to find the candidate key. Okay, just consider this option. Don't consider any other option. Okay, this question only. You have relation R and you have set of functional dependency, and I need to find out the candidate key for this.
First, we have to find the set of super keys. Then from that, we have to find the candidate key.
How will you find the set of super keys?
So, I mean, first we have to find the, I mean, A, B, C, G, H, I. This will be a super key. And then after that, I will start omitting all the attributes which are dependent on another attribute, which are functionally dependent on another attribute, and I will find the smallest. I will find the candidate key.
Okay. See, that will be too much, right? Too much workout, right? Say,
Sir,
suppose.
Can I tell an idea?
Yes.
We will take the combinations of determinants over here. Only we will take the combinations of A, B, and G and C, and we'll try getting super key and candidate.
Why A, B, and G and C?
Because for H and I, we don't have any dependency, right? As determinants.
Okay, so we'll discuss. Okay, see, if you have given any relation R and you have set of functional dependency and you have to find out the candidate key. So what I said earlier, if you take the closure of any attribute and it is giving all the attribute, this relation R, so that attribute is basically a candidate key or super key, right? Because every candidate key is a super key, right? Now, if you take A and take the closure of A, just see whether it is determining all the attributes or not. Then take the closure of B and take the closure of C. Okay. So in this way, you have to check whether we are getting all the attributes present in the relation R or not. Okay. Now, the other way of finding out the functional candidate key is just look at this functional dependency thing. Okay. So A determine BC, GC determine H, and B determine I. Okay. So on the right hand side, we have BC. Okay. So this we can determine from A. We have H. From GC, we can determine H, and we have I. So from B, we can determine I. Okay. So B, C, H, and I. So B, C, H, and I. Okay. So this attribute we can determine from other attribute, right? But what is remaining? A and G. Now, if any attribute which is not present on right hand side of any functional dependency, you have to consider those attributes first. Means here in this case, A and G is not present on any right hand side of any functional dependency. Now this AG must be a part of candidate key. Okay. It can alone be a candidate key like AG, or it can be a combination of with other attribute also like AGI or something, right? So now this AG must be a part of candidate key. Okay. Now if you take the closure of AG, are we getting the whole relation R here? Yes, because A, G will itself determine AG. From A determine BC, I am getting BC. And from this B determine I am getting I. And from this GC, so we have G and C here. So we are getting H. So we are getting all the attribute from this AG, right? So AG is the candidate key here, and it is a minimal also, okay? Because it is not, no one is determining A and G, because these two attributes are not present on right hand side of any functional dependency. So that is one of the trick here. But in some cases, it may happen that both A and G will be present on the right hand side of functional dependency. So in that case, what you have to do, just take a closure of A, then B, then C. Then if it's not giving the whole relation R, then you have to go for the combination of an attribute. Then you take the closure of A, B, then take the combination of B, C, and G, and so on. Okay. You understand this concept, what I explained to?
Yes, sir.
Yeah, so in this example, AG is a candidate key. Okay, so this option is not correct because every candidate key is a super key. So AG is a super key also. So this one is correct. AG is the primary key or not? So how we can say that AG is the primary key? Does anyone? This option is also correct because we've already seen how to find the closure of A plus, right? Does anyone? Those who answer option C as a correct answer. Can you please
Yes,
explain?
as AG is a super key and we don't get any minimal subset, so that AG is also a candidate key. So we get it from there.
Yeah. So basically, what is the purpose of doing such thing is, first we have to find out the candidate key. Okay. Because say suppose we have this attribute, 6 attributes, and let us take example. We have say AG is the candidate key, and say we have one more candidate key. Say suppose AH. Okay. So these two are the candidate key. Okay. Then in that case, we have to decide from this candidate key we can make any candidate key as a primary key. Okay. So the database design process, first we have to find out the candidate key. And among that candidate key, we can make any one key as a primary key. So here in this case, only one candidate key is there, right? So that is why AG is the primary key here. Okay. If we have more than one candidate key here, then we cannot show that AG will be a primary key or not. It may be or it may not, because here we are two candidate key, AG and AH. Any doubt?
Sir, one doubt.
Yes.
Suppose we have one more letter, suppose a D, which is not part of any of the functional dependency.
D, okay.
In that case, should we add that also part of candidate key?
AD, okay. So in the relation only, D, right?
Yeah, in the relation, the D is there, but it is not part of any of the functional dependency.
Right. Then you have to consider AGD also.
Okay.
Because no attribute is determined in D here, right?
Yeah.
Yeah. So AGD
should be
part of candidate key. Okay. And talking about the part of candidate key, okay. It
Yeah.
may be possible that you will get only AG, but it is not a candidate key. Then you have to check for a different combination. You can try many examples in the practice assignment also, in activity questions also. You can try out that. Okay. Yeah. Did anyone have any doubt in this concept? How to find the candidate key? Because if you didn't understand how to find out the candidate key, in next week we have to start from this only in every question. This is the most important concept.
Sure. Can you tell about prime attributes?
Hello, prime attribute. Okay.
Yes.
So you got it, how AG is the candidate key here. Okay, you understood here, right? AG is the candidate key in this question.
Yes, sir.
Yeah. So what is prime attribute is? So attribute which belongs to a candidate key is known as the prime attribute. So in this case, A and G are the prime attribute. And non-prime attribute is Like those who are not a part of any candidate key. So those are the non-prime attribute. Like remaining C, C, H, I, B, C, H, I. Yes.
Okay, sir. Yeah.
So if there are three candidate keys, say A, G, A, I, and say A, H, then A, G, H, and I will be prime attribute, and the remaining will be non-prime attribute.
Okay, sir. Okay.
Now, this finding out the candidate key is a very important concept, because in week 6 we are dealing with this thing only. Okay, first we have to find out the candidate key, then only we can approach the any question or any concept. Any doubt? Can anyone tell me how many super keys are possible here in this relation R? See, we have AG as a candidate key.
16.
16. Okay. How?
Like we have AG already fixed, and all other 4 characters have the 2 raised to 4 combinations.
Like if we consider the combination of candidate key with any other attribute, that will be a super key, right? Yeah. So here in this case, there are 6 total attributes, and 2 attributes consist of a candidate key. Then 2 to the power 4, that is 16 super keys will be there. Okay, great. Yeah. Okay, I think we can move on to our next question. Okay, I think this last question. Yeah. How many candidates key are there in this relation? Yeah. If you understand what we have discussed just now, you can easily answer this question. Okay, only 7 responses. We'll wait for 2-3 minutes. You have to find out how many candidates key and what are those candidate key also. Okay. Okay, I can see only 10 responses. Anyone didn't understand anything, you can ask. Okay. Let us see. Okay. 2 AG AC. 1 2 2. Okay. 1 AC. Okay, so we are getting very less response, only 10 response. Okay, anyone did understand how to find out the closure attribute? Anyone? Anyone facing difficulty in finding out the closure of an attribute? Okay.
Please feel
Yes.
free. If you are not understanding some concept, we will clear the doubt. So yeah, you can just let us know if there is any doubt in any particular aspect.
Would you please repeat that discussion for the last question you have done, the candidate key finding? Still, I have a little confusion.
Yeah, if you are aware of how to find the closure set. Yeah. If any student face in that don't know how to find the closure set of the attribute, then it will be difficult. And after that's how to find the candidate key and the super key.
Yes, anyone? Anyone can unmute yourself and tell me how to find the candidate key here. Those
Here
who are
we don't have A in any of the right side, so A should be a part of the key. And if you see, G and C are like complementary to each other. Either G should be there to get C or C should be there to get C. So either G or C should be part of the key. And if you see the closure of AG, you will get all the relation attributes, and AC also closure will get all the attributes.
Okay. Okay, genius. Okay. Any other student? Because we are getting very less response. Only 10 responses are there. Okay, let's discuss. Who answered this? Manswita, right?
No,
Soumya.
Soumya, yeah. Okay. I think yes, it is correct. Okay, just 1 minute. Okay, so let us discuss how to find the closure of an any attribute. Okay. So I think students are facing difficulty understanding this part. Okay, so suppose I want to find out the closure of A. Okay. So by trivial thing, A will itself determine, right? So we can say that A will, we take the closure of A, so A will determine itself like A. Okay. Now, from this functional dependency, we can say that A will determine B. Now, that is A, B. From A determine B. Now we have AB, right? Now, if you take the closure of AB, then can we find out any other attribute here? Yes, yes, you can unmute yourself and tell me. Right? Now here, right? Together we cannot find out A, B or alone also, right? So yeah, so the closure of A will be AB only. Now let us take the closure of B. So B will itself determine B, right? Do we have any functional dependency that B can determine any other attribute? No. So the closure of B will be B only, right? Same for C and same for G also, not for G, okay? The closure of C, yeah. Now let's just take the closure of G. Now tell me anyone, yes?
You will determine
G, C, H, right? From G determines CH, right? Yeah.
Yes, sir.
And G, okay, we don't have any. Okay, we want B here, so no, this is not applicable. So this is not applicable. So the closure of G is GCH, right? Now the closure of H, H will be okay. There is no any attribute which will determine the H, right? I or same thing for I. The closure of H will be H only, and same for I plus also, right? Okay, so first tell me, you understand this concept of closure, right? How to find the closure?
Yes, sir.
Yeah.
Yeah, now it is clear.
Okay, yeah. So now, so this is the concept of closure, how to find the closure of any particular attribute set or a set of an attribute. Say if I say AG, okay? As you already discussed, AG will determine AG only. Then from A determine B, we can say A, B, G. It is from A determine B. Okay, now if we take the closure of this, it will give us A, B, G. From G, we can determine CH. So A, B, G, CH. From G determine CH. Also from B and C, we can determine GI, right? So A, B, G, C, H, I, right? So it is giving all the attributes that are in the relation R. Okay. So I think this concept is clear. How to find out the closure of any attribute or attribute set? Because this is a basic thing. Okay. If you didn't understand it, you will not get anything in the next 2 weeks. Okay. Okay. Anyone still having any doubt? You can ask any doubt. No issue. Okay. Now,
sir, AC also you can try once.
AC?
Like AG, AC.
No, I'm just showing them one example how to find out the closure of an attribute. We'll come to the
Okay.
candidate key part now. Yeah. You understand it, right? How to find out the closure? Yeah. Okay. So now let us see. Okay. So let us see the functional dependency part now here. So, okay. So A is determining B here. So B is present on the right hand side. CH is also present. And GI is also present on the right hand side. So B, C, G, H, and I. Okay. So only A is remaining. Okay. This A must be a part of candidate key. Now let us take the closure of A. We have already seen how to take the closure, right? So from A we'll get B only. Okay. So it is not determining all the attributes present in the relation R. So A is not a candidate key here. Now you have to check all the possible combination of A with other attributes. AB, AC, AG, AH, and AI. Okay. Now if you take a closure of AB, so that is AB, right? From A we can, okay, it's trivial function dependency, right? AB will determine AB. From B we can determine anything? No. Okay. Now same for AC. From A we can determine B. So I will directly write it here. Okay. A, C, B. Now we have C and B here, right? It is B and C. From BC we can determine GI. So I can write it as GI also. Now we have G also in the set, right? So from G we can determine CH. C is already here. So H, right? So we are getting all the attribute present in the relation R, right? So this is the candidate key AC. Okay. Now let us check for AG. We have already seen the closure of AG. So AG will determine AG. Then from A determine B, that is B. Then from G we can also determine CH. Okay. Now we have B and C. From BC we can determine GA. So it's already here. So this is I. Now this is also a candidate key. Okay. So AC and AG are the candidate key. Now let us check for AH. Now from this function dependency A determine B, we are getting A, H, and B. Okay. So do we have any other function dependency based on H and B?
No, sir.
Right. So that will be AHB only. Now AI. Now from A we can determine B, right? AIB. So yeah, can we determine any more attribute here? No, right?
No, sir.
So this AC and AG, these two are the possible candidate key. Okay. Because we have checked all the possible combination of A with all the attributes, right? Now, if you take any other combination with AC and AG, say ACI or ACB, anything, you will get the whole relation R. Okay, but that is not a candidate key here. Okay, so these two are the candidate key, AC and AG. What are the prime attribute? A, C, and G are the prime attribute. Okay, and remaining are the non-prime attribute. Right. Now, if you take the combination of this AC with any other attribute, you will get the super key. Same for AG also. Any doubt in this? Whatever I had explained now.
Sir, can there be any AH and AI combinations? I mean, AH and AI are not candidate keys, but AH some dash, AI dash.
AH?
Like 3-letter. Now in 2 letters, we got AC and AG are candidate key.
Right. Yes. This is for the combination of two attributes set. Okay. So if we take the any attribute with these two, we will get the super key, right? Because it's a minimal of the key, right? So this is candidate key. Now you can also check for the other combination, right? AHI. You can check for this also. Do we get? We are getting all the attributes or not? Let us see. From AHI, we can determine AHI. From A, we will determine B. Okay, so C is not present here, so we cannot use this. G is also not present, so we are not getting anything. If you take the combination of more than 3 attributes also, you will not get right. All the relations are. Getting it?
Yes.
Yeah. So there was one question in the activity, like based on the super key, right? So every table, irrespective of functional dependency, there will be at least one super key, which will be a combination of all the attributes, right? If you take the combination of say A, B, C, G, H, I, so it is a super key because it will trivially determine itself, right? So this is the one of the super keys. Every table will have at least one super key. That is the combination of all the attributes. Any doubt?
The prime attributes are ACG.
A, C, and G are three prime attributes are there. Yeah.
Okay.
So why we are finding out the prime attribute and non-prime attribute? So that we'll discuss in next week also. Okay. So first you understand in this, there are very few important concepts. First, how to find the closure. Then second one is candidate key, and also like a prime attribute. Okay. So because these are the basic thing that we need in the week 6 to determine whether our table is normalization form or not, like different types of normal forms are there. Okay. So we have to start with this basic concept only in every question. So this is most important concept.
Sir, decomposition and canonical cover, are we covering in next session or?
You can.
Yeah, we can cover in the next session.
Yeah.
Okay, so I have some doubts in that.
Decomposition.
Yeah, like extraneous, the finding extraneous attribute and that canonical cover and minimalizing it. And
Yeah, we are going to cover that in detail in next session also. Do you have any specific doubt in that, or do you didn't understand?
yeah, some activity questions based on that.
Yeah. Okay. Okay, so we'll take that question also. No issue. First, we'll see. Okay. Any doubt in this part? I think this was the last question. Okay, thank you, sir. No doubt. Yeah. Okay. So please solve the question based on this concept. Okay, it is very important concept. Yes. Who asked that question? Activity question, right?
Yeah, Soumya, it's 5.5 activity section.
The external attribute, right? Okay, I answered that question on this.
Decomposition, lossless, low C, and all everything. It's like bit confused. Maybe I think we can take it next session after you discussing.
Okay, which part activity? 5.5.
5.5. Yeah, actually, almost all questions I have some doubts. The second one I have given in discourse forum, and I am okay with that, but still a little bit confused with how to
there is one
make
tutorial
sure
also.
it is.
Okay. Okay. In the next session, we will cover in detail.
Soumya, there is one tutorial on decomposition part.
Yeah, but still that third question, if you see like that adding B to C makes lossless, B to D makes lossless, C to E makes lossless. Like I'm not.
You have to work out those example in detail. Just first check whether R1, R2, R3 is a lossless decomposition or not. If it is not, then just go through options. If we add this B determines C in the functional dependency, are we getting the lossless decomposition? If no, then just go for next option. If we add B determine D in the given functional dependency, are we getting the lossless decomposition?
Here, actually, both A and B are the correct answer they are saying. So that means we should add both to make it lossless, or any one of the two will make it lossless.
Either A or B, either.
Either.
Yeah.
Either. Right.
It is MSQ question, right? Yeah. So we have to take option wise. Okay. If we add B determine C, it will make a decomposition lossless or not. If we add B determine D, it will make a decomposition lossless or not. Yeah.
Okay, I'll work out and I'll maybe ask again in the next session if I have still doubt.
Okay, sir.
I have a
And
tutorial also on that. Yeah.
And the last question in this 10th question in the same.
Yeah.
Here we have 4 attributes and split into 3 and 2. So
Yeah,
they're
yeah.
asking minimum number of functional dependency. So we have 3 condition. Intersection should not be null set. Union should be R. And the third one is at least one should be the key of the common attribute should be key of the one of the.
Yeah, right.
So because of that, it is showing that is minimum is 1 here. Because minimum is B determined D is like one mandatory thing.
Yeah.
Because of that, here the minimum number is 1.
Yeah.
Yes. Okay. Common attribute is B, right? Yeah.
Okay. Thank you.
Yeah. In the slide also there are many practice questions based on this decomposition part. Okay. You can solve those questions also. And yeah, we'll take those questions in next session also. We can take that.
Okay.
The slides only there are a few very good questions, right? It decomposes into four or more relations. So that question you can try.
Can we get an answer for that also? Because if we try it out just to make sure that it's all correct.
Yes. Okay. We'll provide that.
Yeah, thank you.
We'll discuss that in the live session. Okay? And we'll see, okay, if we can document it. Yeah. Yeah. Any other doubt?
Sir, I had a doubt from previous week, sir, in exist clause, sir.
Okay.
So the thing is, what I understand how exist clause work. I am just checking it with you that if it is correct or not.
Okay.
So in case of an exist clause, I have to first it will find whether the inner query is empty or not. So
yes.
So if it is empty, then it will return false, no doubt. But if it is
Yes.
not empty, then it will check if there is any condition attached to that exist clause or not, like where, any where clause attached inside that inner clause.
Yes.
Okay. Now after that, it will after implementing that where clause, it will check if that it is after implementing that where clause, it is getting a non-empty set. Now it will implement that where clause in the outer query.
Yes.
Non-empty set. Okay.
So I mean that's how we are getting the result from this exist clause. Am I right, sir, or is there anything I need to know?
Yeah, you are right.
Sure, but if within exist clause, if we get more than one tuple, and if the outer condition is equating to only one tuple, then it gives an error, right?
More than 2 condition means joining tables more than 2 condition, right?
Sir.
Okay, wait, I will present my screen to you later. Okay, so suppose there are 2 tables, okay. Say this is S1 table. We have SID, SName, and age. Okay, so this is S1, S2, S3, S4. Name can be anything. Ravi, Ash, then Shami, anything. We can get Piyush also, right? Age is 23, 24, 25, 26. We have one more table, say C1. here we have, okay, so SID will be the foreign key here, then CID and CNAME. Okay, so here S1, C1, say DBMS, and here say okay, S4, say C2, Python. Okay, now my query is select star from S1 where SID exists, then select okay, select SID from C1
Sir,
where
sir, SID will be not there. SID column.
which column?
After where clause?
Here.
After where clause? SID is not there.
SID
Yeah,
is there, na? In S1 table.
No, in exist clause. That only exist clause is there. If it returns the true values, then it will be satisfied.
Exist.
This SID.
Yes, SID equals to this one. This C1 not SID. Yes, by what you are saying?
After where clause, we only take the exist.
Where exist?
SID. You mentioned.
Yeah, so who asked that question? Okay, now tell me your condition, what you are saying. So this is S1.SID equals to C1.SID.
So sir, this will fetch me the first and last row of this first table.
Yeah, so based on this condition, it will check. So S1.SID equals to C1.SID. Okay, so this is true, right? So this exist is true.
Yes. Yes.
So this will fetch this this tuple. Then it will check for S2. Okay, so S2 is not present, so this is not true. Exist condition is not true here, so it will not fetch this one. Similarly, this one also. Now
Sir,
S4, yes.
So if I omit the where clause, so it will fetch all the rows, right?
This one.
Yes, this where clause. Yes, sir. Yes, sir. If I remove this where clause from the inner, yes. So
Yes. Yeah, this will fetch all the row.
Select SID from C1. So this will be always true, right? It will be always true, na? This select SID from C1, right? If you omit this where clause.
By true, you mean I will get I will get a non-empty set. I will get a non-empty set from this inner clause, inner query.
No, it is only checking whether it is true or not. So select SID from C1. So yeah, if you run this condition only, so this condition will be true, right? It will select all the SID, right? It will. So what this will
instead of SID, if I write CID, then also it will fetch me all the rows.
Yes.
Yeah, it will fetch all the row.
Yeah.
So basically, I mean that thing where you are telling that it is true or not, basically it means that it is checking whether this inner query is fetching me empty or non-empty set. Depending on that, I am determining. It is determining whether it is true or false.
Yeah.
Right. Yeah.
So then, can we say that exist clause is used just for true or false, and we can't equate any? If, as you have written before, sir, SID equal to exist, we can't do that, right?
SID equals to C dot SID.
Not over here, sir. In the out.
Yeah. It will return true if there is in inner clause written any set of result or not. Means if their result present or not. If present, then it returns the true value, and if there null set, empty set, then it will return false value. Yeah.
And if it is true, then it finds some where clause, then it will compute that where clause and give me the output.
Yeah, whatever you want to run inside the that inner query, that will be up to you.
Yes.
That condition must be satisfied, right?
Yeah.
Okay. Thank you.
Yeah.
Okay. Okay, any other question?
Sir, we cannot write tuple relational calculus in PG admin, no?
No.
Sir, then why are we learning this and where to use this?
Prajwalit, what you? I'm not able to get you.
Sir, these tuple relational calculus and domain relational calculus and relational algebra that we learned, and so we cannot write query based on these in PG admin.
Yeah, it is suppose there is a query, it is very difficult to write the first time in the SQL query. So we first express in the mathematical expression, and after that we write the relational algebra. After that, seeing the relational algebra, we write the SQL query.
Okay.
For the complex query, it says what we are provided that are the simple query. For some industrial, there is the difficult query, right? So it will be easy for you to there.
Yeah, means we have to first. These are the basic steps to come for SQL query.
Yeah.
So you should able to interpret the TRC and DRC part. Okay. So suppose I don't know anything about SQL, but I know how to write this TRC expression, relational calculus expression. Okay. So I want certain data from the table, but I don't know how to write the SQL query. So what I will do, I will write the TRC expression and I will give it to you. Okay. So you have to convert the TRC expression in the SQL form. Okay. And give me the result.
Okay.
So can we take a question from mock?
Mock, okay, so we have just released yesterday only, so let others also try. Do you have any doubt or you didn't understand?
Yeah, sir. In the question, sir, actually.
In the question you have doubt, okay.
Yeah, question number 16, actually.
Question number 16, yeah. Can you just refresh that mock page, mock test? We have updated that question.
Okay, sir, I'll try.
Yeah, the designation and department, right? Inside the...
yeah, that one, yes.
We have updated that. Instead of department, there is designation, not designation ID.
Okay, sir, I'll check.
Yeah. Just refresh it, yeah.
Sir? Sir, the thing that we are learning in this week 5, so we do this to develop a database, right?
Designing a database.
Sorry, but design a database, right? So do we do this all in, all in pen and paper, or do we do this by using some kind of, like, for finding the closure attribute and all this and all these dependencies and all this? So do we use some kind of software, or do we do this in pen and paper?
About the software, I don't know, but this is the conceptual part. So yeah, we should know about this concept whenever we're designing the database, right?
No, sir. I understand that. I mean, just out of curiosity, I was asking that we use kind of software while doing some industrial level thing. Do we use software, or do we just out of curiosity? It is not a doubt or something like that. Out of curiosity, I was asking.
I don't know whether the softwares are available for that, like for this thing. I have no idea about that. But the basic requirement for this is like, if we know about the functional dependency part, then we can determine what will be our possible candidate key. Then we can decide the primary key. Okay. Then during the normalization, say if we have any data, there may be redundancy in that data, right? So in order to remove that redundancy, we'll go for the normalization part. Okay. So then that whenever we decompose one table, so that function dependency must be preserved. Okay. So that thing we'll discuss later also. I think in the next week we have that normalization part and dependency preservation. Any other doubt? Please go to the mock test. Okay, we'll discuss Saturday session. You can post on a Discourse also, no issue. Yeah. Any question? Okay. Yeah, you can see the question number 16 is updated now. Yeah, you can try that question. Okay, thank you everyone. Yeah.
Thank you. Have a nice day.
Thank you, everyone.
Yeah, thank you. Have a nice day.
Thank you all. Have a good day.
Sir, वो sir 90